In this video, we will talk about the third type of trigonometric integral. So in the previous video, I already talked about case 1 and case 2. What is the characteristic of the third type trigonometric integral? So unlike the first two types, type 1 has sine and cosine raised to some power. Type 2 has tangent and secant raised to some power. Type 3 has sine and cosine, sine times cosine, cosine times cosine, or sine times sine raised to no power. It's just first power, right? So we already talked about case 1 and case 2 in the previous video. We are going to talk about case 3. So case 3 is a cosine times cosine in the integrand. Let's take a look at the first problem. We have cosine of 5x times cosine of 10x. We are taking the integral of that. So this matches to case 3, and a is equals to 5x, b is equals to 10x. Let's plug it in to the product to some identity. So that is integral. We have 1/2, and then we are matching this to the blue identity. So cosine a minus b, that is 5x minus 10x, and then plus cosine 5x plus 10x. Close the square bracket dx, and then we do the minus and the plus. So that is 1/2 cosine negative 5x, and then plus cosine of 15x, and then dx. So now we are ready to integrate. So let's put the 1/2 right there. The integral of cosine is equals to negative sine. Oh, actually the integral of cosine is equals to sine. So we have sine of negative 5x, but we have to prepare a negative 1/5 in front of the sine. When you take the integral of sine is equals to cosine, right? By chain rule, you need to take the derivative of the linear function negative 5x. When you do so, that gives you a negative 5 because the slope is equals to negative 5. So in order to get rid of this negative 5, you have to prepare a negative 1/5 in front of the sine. So simply take the derivative of that. You can go back to cosine of negative 5x. And then the other one plus the integral of cosine is equals to sine of 15x. And then you have to prepare extra negative 1/15 in front of the sine. So the integration is done. And then you distribute the 1/2. So you have negative 1/10 sine of negative 5x, and then plus 1/30 sine of 30x, not 30x, sine of 15x, and then you plus c. This problem is not done yet because if you are doing your homework online, the system might not accept the sine of negative 5. So this, you have to remind yourself the odd and even properties of sine and cosine. Sine is odd, so sine is odd. Cosine is even. For odd function, you have sine of negative x, that is equals to negative sine of x. That is the characteristic of odd function. For even function, you have cosine of negative x, that is just equals to cosine of x. So this one, you actually have to take the negative out from the 5. So that means at the end of the day, we have 1/10. You are going to take this negative out. So negative becomes positive sine of 5x, and then you plus 1/30 sine of 15x plus c. So that is the final answer to the first integral. So if you take a look at the second integral, does the second integral matches to any of the cases? The second one in pink, does that matches to any of the cases? The answer is no. All right. Then how do we solve this then? That doesn't match to any of the cases. Then we will have to figure out something for the cosine of 2x. So this integral, if you use u substitution, that is clearly not going to work. If you let u equals to 1 plus cosine of 2x, that is not going to work. You can try, but that is not going to work. So what will work? You will have to use the double angle formula. So let's copy the problem down. and then I will show you what do I mean by the double angle formula. We have integral from 0 to pi over 6 square root 1 plus cosine of 2x dx. So I am going to rewrite the cosine of 2x using the double angle formula. Double angle formula. For cosine of 2x, there are three double angle formulas. The first one is cosine of 2x equals to cosine square minus sine square. This is the first one. The second one is cosine of 2x equals to 1 minus 2 times sine square x. The third one is cosine 2x equals to 2 cosine square x minus 1. There is one for sine. Sine of 2x has one formula only. That is 2 times sine x and then cosine x. Of course, we have this for tangent, but the one for tangent, you won't be used that very often. So which one should I use? I am planning to use this one in this problem. So let's do the rewrite. So we have integral from 0 to pi over 6 square root 1 plus 2 cosine square x minus 1 and then dx. Now we have a 1 minus 1 that is equals to 0, right? So 0 to pi over 6, we have the square root of 2 times cosine square x dx. So when you take the square root of that, the cosine square becomes a cosine. Then you have from 0 to pi over 6, the cosine square becomes a cosine. And then what about the square root of 2? The square root of 2 is just the square root of 2. And then now you are ready to integrate. You are ready to integrate. What is the integral of cosine? The integral of cosine is equals to sine, right? Sine of x, and then the root 2 is in front of that, such that x goes from 0 to pi over 6. And then you have root 2 times sine of pi over 6 minus root 2 times sine of 0. Sine of 0 is equals to 0. Sine of pi over 6, you have to recall the unit circle. The unit circle. So sine of pi over 6, just if you don't know what a unit circle is, you have to look it up right now. It is something that it is a topic that you study in trigonometry. So for unit circle, the point pi over 6 has this coordinate. We have a root 3 over 2, comma 1/2. And then sine refers to the y coordinate. So that's why the sine of pi over 6 is equals to 1/2. So you have root 2 times 1/2 minus root 2, sine of 0 is equals to 0. So overall, the answer is equals to root 2 divided by 2. And this is the final answer to the second integral. Alright, so that is also the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel if you haven't done so. Appreciate your help and support. See you all in the next one. Signing out for now.